Phospholipids are our last kind of lipid or fat that we're going to learn about. So phospholipids is how you say this. Most people have never heard of phospholipids. They're probably some of the most common molecules in your body, believe it or not, that you've never heard of. And that's because phospholipids make up the majority of the cell membrane. So every single cell in your body is wrapped with a membrane that kind of holds it in like a baggie. And that baggie, the actual membrane itself, is built of phospholipids. So there is bajillions of phospholipid molecules in you. Every single one of your cells is wrapped in a phospholipid, but wrapped in something made of phospholipids. So what does a phospholipid look like? Well, there are 1, 2, 3, 4, 5 different diagrams on this one slide of a phospholipid, just showing it in different ways. So I'm going to start with this diagram here. All right, so a phospholipid starts off almost like a triglyceride. So here is our glycerol backbone. So 3 carbons, 1, 2, 3 in a chain. And normally the glycerol has 3 hydroxyl groups. And if you're going to make a triglyceride, you put a fatty acid on each hydroxyl. So you start like that. You put a fatty acid on the first one. You put a fatty acid on the second hydroxyl. So we have 2 fatty acids. But instead of putting the third fatty acid, which is what you do for a regular triglyceride, you don't do that. Instead, on that third hydroxyl group, you stick a phosphate group and this big thing with a nitrogen and a bunch of methyls, all kinds of stuff up here, right? So on that third hydroxyl, you put something different. And the thing, it doesn't really matter what it is specifically. What does matter is that there are charges here. Look, there's an O- there and there's an N+ there. So we have charges up here at the top, all right? So that fundamentally changes how this molecule behaves. Now remember, these fatty acid tails down here, they're just made of C's and H's, and there's no partial charges, there's no charges here. So the tail has no charges, but the head does have charges. Now, if you think back to a couple of weeks back, and we talked about how water interacts with different molecules. Water molecules are attracted to molecules that have charges or partial charges. So water is going to love to be up here. Water likes this, but water hates this. Because this has charges, so water's attracted here. There's no charges here, so this wants nothing to do with water, and water wants nothing to do with it. So we have a molecule that can't decide. Its head, the top part, really loves water. Its tails, its bottom part, just wants to avoid water at all cost. So this molecule is conflicted. And we symbolize that, or we show that by when we draw the molecule out like a cartoon, we show that there are 2 parts. There's a head, which likes water, and there's tails, which don't like water. Also on here, you can see they've got hydrophobic tail, hydrophilic head. All right. Another diagram of the same thing. Here are the tails right here. And then here's the head with the charges. All right. And once again here, head, hydrophilic, likes water, tails, hydrophobic, stays away from water. And one more picture. All right, so this is a phospholipid. Hydrophilic head, 2 hydrophobic tails. I mean, that's as artistic as you have to get here to show a phospholipid molecule.